Welcome, everybody. Today, we're going to be working on Unit 3, and we're going to talk about some important concepts here. We just finished up Unit 2, and in Unit 2, we learned basically what a database is, how to run basic select statements, and focusing on individual tables within a database. As we move into Unit 3, our goal is going to be to start to learn to retrieve data from two or more tables at the same time, because often, the whole point of a relational database is to not repeat redundant information. So, like, I don't want to have, all my customer demographics in my order table, for example, or all my order information in my customer table, right? So we put them in separate tables, and then we link the tables together to get more complete view of the information. And so when you run a query, it's helpful to be able to do the same thing. So, like, in other words, if I want to run a query that selects a customer from my customer table and then looks at my, like, which products they ordered, well, that's like three different tables right there, right? And if I want to look at which product, when did they order, and the customer stuff all at the same time, well, I have to write the query to address all of that. So that's kind of our concept. Now, a lot of the terminology that we use to do this draws a little bit from some areas of mathematics that a lot of us dread, real frankly, called set theory. And I'm just going to do a little drawing on the screen here, and then you guys can curse me later, I guess, in terms of my drawing capabilities here. But I'm going to try to draw on the screen here, kind of in the white space. But you notice I'm making a rectangle, let's call it, and that's like our whole, like, universe or whatever. And then you learn this kind of stuff in set theory, where basically you have like one, like, circle or table or construct, and then maybe you have another one, and then this is the whole universe in which they exist. This is the portion that's in this circle, that's the portion that's in this circle, and sometimes these circles overlap and they share certain things, right? And if you want to get really weird about it, you can add more circles and they can overlap. And some of them just overlap across two, and some overlap all three. You see the concept. And when we start to work with database tables, this silly little graphic actually kind of applies, because we might have, if each one of these is one of our tables in our database, and we're looking for very specific aspects of the data. So we want maybe all of the stuff in this circle and that circle combined, or maybe we just want where those two circles overlap, or maybe we want where those two circles overlap but don't overlap the other ones, right? So you can, like, any of the little areas that you see on the screen, we can write queries to get that information, and we're basically taking things and we're joining them together, or we're finding their intersection or their union, and all that weird nomenclature and stuff kind of falls into this area. So when you think about, like, joining stuff and doing unions and stuff, that's kind of where the ideas come from, right? So now we have to do this in a more practical way. What I'm going to do is I'm going to transport us over to W3 Schools, where we're going to absorb the material from there. And I think I'm going to try to be brave here, and I'm going to launch my Brave browser, and I'm doing this on purpose. Why would it? Have you guys ever heard of this browser, by the way? The Brave browser, right? So IT people in the know usually know about this one, but the Brave browser is like Microsoft Edge and Google Chrome, built on what they call the Chromium code base. So this is basically Google Chrome under the hood, but the Brave browser does stuff automatically that other browsers usually have to get extensions or plugins for them. So, for example, like, if you run Google Chrome and you get sick of all your ads on web pages and ads popping up, or ads that play in the middle of your videos on YouTube, that kind of thing, you find like a pop-up blocker and an ad blocker and a tracker blocker and all that stuff. Well, guess what? Brave does all of that automatically. You don't have to make any special settings. It just does it, right? So often and I'm trying to be smart about this in class because I often play videos and ads pop in, and I don't want to do that. So we're going to see how well this handles all the ads in W3 schools. My goal is to omit the ads basically as we're doing this. So I'm going to take my links here, and I'm going to paste them into the Brave browser and see how much of the ads we're blocking. Well, some ads. Okay. We'll see, right? This is an experiment, but we are looking at this through the Brave browser. All right. So one of the weird things that we already did today, by the way, right? And when we were doing the Unit 2 assignment, we were asked to take last name, comma, first name, and then combine them and display them as a column called something else. So if you, for example, look at a database table, and I'm just going to jump into one that we have open here. I'm just going to like show you an example. When people are naming database columns, they use these names that like are ugly, real frankly. Why? Okay, so why are they calling it shipping underscore address underscore ID? Couldn't they just call it, I don't know, couldn't they put some spaces in there, throw in some capital letters, or use like prettier punctuation and a better font? I'm just being kind of silly here. But the point is, when they're building these columns, the reason that they don't put spaces in them is because database systems don't like that, basically. It's not that it's impossible to do. It is actually very possible to do, but it's the general convention in the database world is database column names never, ever have spaces. And the convention is, or one of the conventions is what we're looking at, which is you can use the underscore approach. So wherever you would put a space, you use an underscore instead. And I mean, I can read it and I can go, okay, yeah, the shipping address ID, got it. Right. And that's not really a bad name, but sometimes you get these weird column names that are like, oh my God, that's horrible looking. Why would I do that? Another approach that people use is they'll use what we call camel casing, where it might be like shipping, capital A address, capital I, capital D, that kind of thing, with no underscores, and then the capital letters designate the separate words, right? This is just so it's easier for us to read. But I think in general, most database admins tend to think that this approach is kind of the best approach. I will indicate, though, that a lot of the column names and table names here are all lowercase, where like in the Microsoft world, everything's like uppercase and whatever, So there's no rules, but just be consistent would be my recommendation. So if you're building from scratch, you're the person making the database, these are things that are under your control. Question that some people might have is, if I create a database and I create a column name, can I change the column name later? Right? Yes, you can. It's not pretty, right? And it's not really the way you should work. So often when database people are building new databases, they sketch the whole thing out first before they build anything, and all detail, right? And then they go to the technology and build it. And yes, sometimes they use tech tools to do the planning and then tech tools to build it. But whatever. The point being, that's one of the weird things about this. And more importantly, if I'm creating a report for somebody and I'm doing an output, this name doesn't look as good as what if I just said, a ship ID or something like that, or shipping address ID with this like spaces and capital letters. Can I just do that, please? That kind of thing. And that's what the aliasing is really about, is to create output names that look better than the column name that's already in the database, right? And so, for example, like, and you notice all these examples are very, very similar to the stuff we're working with. So here it says select customer ID, and this is an example of camel casing, right? Capital letters instead of underscores. And when we show that, well, we know we're looking at customers. You know what? So I don't need to have it say customer ID. Can we just call it ID, please? Right. And then when I'm looking at the customer name, well, they're a customer. Can we just say customer? Instead of customer name, right? And so let's just run this really quick just so you see what I'm talking about. But when you run the SQL code, what'll happen is the output, instead of having this ugly name has this, instead of this ugly name has that. Now, I think with our example where we have underscores, those are even more ugly than this. But either way, this is more readable, right? That's kind of the point. And especially if you're going to be taking the work and showing it to somebody else as part of a report, right? Your manager doesn't want to see the underscores. They just want to see customer name. Yeah, thanks, customer. That's the thinking here. All right. So that's the concept of aliasing. So when do you use aliasing? Well, whenever you feel like it, real frankly. But generally, I would use this rule of thumb. If I'm running a query because I just want to see what happens, or I want to see if the data is feeding correctly, it doesn't matter. If I'm creating a report or output that's going to go to somebody else, right, and then further be processed, aliasing becomes important because it's your opportunity to change the name of it to something that might be useful to the person that follows. That's the thinking. So, all right, let's move on to the topic of joins. And I am, once again, utilizing my friend here, the Brave browser. All right. And so far, so good. It's blocking most of the ads, right? No reason to, those advertisers are getting their fair share. So. All right. Notice the only ads that don't get blocked are the ones from the native site. So I guess we're doing all right. The other, this is sideline again. The other interesting thing is, it's told me that tracker ads and more things. I've already blocked 10 things since I've been online, by the way. All right, let's look at this concept now of joining tables. And as I mentioned before, it's not unusual in a database that we separate data to make it more efficient to store. And then when we want to retrieve information from the database, sometimes we have to query a table or two or three or whatever it takes to get the information that we need to get the output that we need. So we have a special clause called the join clause that allows us to join stuff from two or more tables, as it says here, based on the fact that there's a relationship between the tables. So I want you to think about this really carefully. If I have a table that holds the orders for my customers, and I have a table that holds my customers, if I have a customer that doesn't have an order, there's nothing to join, right? If I have a customer with, let's say the ID of 123, and my customer number 123 has placed many orders with me, he's going to have many listings in the order table, and therefore there is something to join on. But here's the larger concept. The piece of information that joins the table together are columns that are shared by both tables, right? So from a practical sense, like if we go to the database that we've been working with, and let's say we look at a customers table and an orders table, and I'm just going to run this one so we have them both on screen to look at. So here's the orders table that we have, right? And you notice there's a customer ID column. And if I go to my customers table, there's a customer ID column. So it stands to reason that, let's say customer, I don't know, 2, Barry Zimmer, when he's listed here, that's Barry Zimmer, right? So this customer ID 2 matches this customer ID. And more importantly, this whole column is the same piece of information that's this whole column. So those two columns are related. That's why we can join them. In the absence of that column, is there any other way we could join these tables together? Okay, so how would we know that? We have to look at the data, right? So customers have, ID, email, password, first, last, shipping, billing. Okay, orders, we got order ID. Okay, here's one in common, but we have order date, ship amount, blah, 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 blah. None of this stuff is in my other table. The only column that matches up is the ID column. And folks, by the way, that's a very common scenario, right? And so one of the reasons we even create ID columns is usually to uniquely identify an entry in a table. Now, customer ID is the unique identifier in my customers table. In my orders table, it's actually my order ID that's my unique identifier. And somebody's saying, do they both have the ship address ID? They might both have the ship address ID. Okay, so they might have, oh, I see. So ship address ID must match up with the addresses table. And yeah, they both have the ship address ID. So I'm noticing though, like Barry, he's got a different shipping. Barry's got two shipping addresses, right? So that I think that's kind of the point there, on that one. But somebody dropped that in the chat, so I thought I'd address it. All right. So going back to this concept though, that when I have a table, and the customers table is a really good one, where I have some sort of an ID field that uniquely identifies each entry. And what that means is I have one Ellen Sherwood with a customer ID of one. I cannot add another customer that's got an ID of one because that one's already taken by Ellen. Right. And therefore, this column, the customer ID column, is, and we'll go deeper into this later in the course, is what we call our primary key. It is the index field for the table. And whatever is a primary key, it means that the values in this column must be unique. None of them can ever be repeated. So whenever I add a new customer, that customer ID is going to keep climbing. And you want to do the comparison, think about your student ID here at Gateway, right? We use that to drive everything about you, your report card, your bill, your grade, whatever, all of it is related to your student ID number. If you call somebody, it's like, what's your student ID? That's how they look you up, right? That's how they find you in the database. In the orders table, right? Order ID is the primary key. And then what happens here is customer ID is basically our link back to this table. And in this situation, once again, we'll talk about this later, we would call that a foreign key. So in other words, if somebody is going to be in this column placing an order, this customer ID better exist in my customers table. Otherwise, the person can't form or can't create an order. Right. So that's part of the process of it as well. And once again, we will talk about these concepts more deeply. But the point is, when we do a join, we have to have a column, at least one column between the table to join with. Otherwise, we can't do the join. Another thought here is like shipping address ID. I'm assuming, and we'll take a look at the address table here just for the sake of whatever, just to show you what the query is. Yeah, even this doesn't have the shipping address ID. This has the customer ID, and it's got an address ID. Isn't that interesting? But you notice that those customer one has two shipping addresses. Customer two has one. So I was wrong about Barry having two addresses. It's that first person's got two addresses, right? And anybody here that's listed twice has two shipping addresses. And that happens, right? You drop ship to a friend, or drop ship to work, or drop ship to home, or send it to your PO box, ship it up north, etc. All right, so that's kind of the thinking there. All right, let's go back here now, and we'll take a look at this orders table, right? These are the same concepts, by the way, right? So there's an order ID, and the order ID ties it to a customer through the customer ID. And then we can look at the customer IDs, right? And then these two tables link on that field. So if I wanted to, this is where we get into a little bit more complex syntax here. This is why we slow down a little bit and take a look at this carefully. Notice that when I'm joining across tables, I am now including in the column select statement. So this is the column. This is the table. So from the orders table, I'm selecting orders ID. From the customers table, I'm selecting customer name. From the orders table, I'm selecting order date. Okay, so this is where it's weird. But why are you just listing orders here? Well, I got to pick one. That's the why. Which one is primary to me? Well, in this case, we're selecting orders. Why? Because there's two of them from the orders table. Then we're adding this statement after the from statement. We're saying then we're doing an inner join. So this is the connection between the tables. So we're pulling from orders and we're doing an inner join on the customers table. What fields are we using to join? And this is going to require, I want you to remember this, you got to look at your tables to figure this stuff out, right? So we're joining on the fact that the orders or the customer ID in the orders table is also the customer ID in the customers table, and those are equivalent. So wherever those are equivalent in those two tables, that's what we're joining on, right? That's where the circles are overlapping. The information's in both tables, so we're overlapping circles. Right? And then when you run this, right, so we'll just run the SQL statement, you can see the output. Notice how it comes out. So it's showing us the order ID, the customer name, and the order date. The information is coming from multiple tables with two tables. The tables are joined together, and they're joined together where the customer IDs are equivalent. Right. And this is called an inner join. And we think of this as like a basic join statement. Now, remember, I was drawing circles. W3, I guess, is doing the same thing. And, you know, so when we start using different types of join, so there's more than one type of join, and this is where it gets weird. But an inner join is where they overlap. And that's the scenario we were just talking about. So I'm only including records where this customer appears in both tables. And so we're only looking at the overlap. That's the inner join. If we do a left join, it returns all the records from the left table, but only the records from the second table that overlap. If we do a right join, it's the converse. And then we can also do a cross join where we just kind of join it all. Now, what I will typically say is most of the time you're looking for inner joins, like not always, but let's just say like 90% of the time. I'm throwing a number out there. I'm not sure if that's anywhere near real, but whatever. For me, it's most of the time, right? Then when you have the scenarios where, all right, I want the output here. I want to see all the orders, and then I only want to see the customer stuff from the customers that ordered, you know, because I might have a bunch of customers that didn't order. So I just want to see the customers that ordered. That's kind of the scenario, right? So those are all the different types. And then you can experiment with those, and the scenario will dictate which type of join you do. And by the way, we just looked at inner join. Let's just do a really quick look at like a left join. And I don't want you to freak out to this stuff, by the way. But let's take a look at their example, right? Customer name, orders, order ID from the customers table, right? They're considering customers primary. We're left joining to the orders table. We're still using the customer ID, and then we're ordering it. But let's take a look at the difference on this, right? And I'll run the query, and then I'll do an inner join. You can see the difference. And notice here how Alfred's, who's ordered a bunch of times, now we're seeing his record over and over again, because we didn't say, hey, we just want to see customers that ordered. Now we're seeing every order the customer placed too. You see what I mean? So these are customers that have placed orders, but now we're seeing all their orders. If I did an inner join, provided it still didn't work quite right, but anyhow, and I think I'm probably would need to engineer this better. Basically, we would only see the one, and maybe I need to change the order of that, but let's not go there right now. Okay, that's not really the grand point of this. As we get into the situations where we would use these other joins, we will talk about them, but we can also use, by the way, just the keyword, and this is kind of the point here. We can just use the keyword join to do the work in the inner join situation. And the why is because that's the default join, is the overlap of the circles. Right. So I'm going to run this again, and I'm just going to show you that if let's run it. Let's see the results. All right. Now I'm going to delete up here. I'm just going to delete inner and run it again, and it should still work. And notice it works exactly the same. Right. So when we're coding here for class today, my tendency is to just go to join instead of inner join. And if I remember, I'll type out the whole thing. But everything we're doing here today is just an inner join. All right. Moving on, next topic. If I can find that next topic. Here we go. Left joins and right joins. And I'm going to take we took a really quick look at the left join. Now we're going to look at the right join. And this one's going to go the other direction, by the way. If you remember, we were looking at the left join and it had like multiple listings for each person. This one is orders and employees, right? And we're doing a right join where the employee IDs are equivalent. So in other words, this must be the person who made the sale, I'm guessing, or the salesperson or the rep or whatever. So let's just run this and then take a look at the output on this and look at the difference. Now notice that we have discrete people here, and it looks to me like we're getting all the sales people here, but I don't know if you guys are picking up on this at all, right? Is this the only listing for Buchanan, right? And if you look, right, and start scrolling through here, you're going to notice that some names appear over and over again. So now we're prioritizing. So the prioritization here is on the orders as opposed to the salesperson, but we're seeing every order that the salesperson made, but the order ID is primary. We're ordering by that. Right? So that's the difference between a left join and an outer join. All right. I think that covers most of the information that we need here. One other thing that I did want to talk about, because we can kind of using these and haven't really talked about them, are these keywords and or in not, right? And and here I am saying and or and whatever, and these are words that we throw around a lot, even conversationally. And for any of you that have coded before, so like if you have done regular programming code and you understand what an and an or and a not are, those are what we call logical combination operators. It basically operates the same way it does in coding, right? But sometimes, and where we use this the most is when we do condition clauses. All right, so we're selecting these columns from this table where this condition happens. Okay, we've done that, right? But sometimes we have more than one condition. So we'll say and in between. So maybe we're checking 3 conditions, but whenever we use the keyword and, right, all the conditions must be true. So if I'm testing 3 conditions, all 3 of those conditions have to hit to get a result, right? Conversely, if I'm using the or syntax, only one of these needs to hit to be true. And requires everything, or only requires one. Okay, so you just have to pick one. And not, well, not is simply an inverse operator. So if I'm looking for something to be true and I say, well, we're not true, well, I'm looking for false, right? Or something that doesn't match the condition, whatever that happens to be, whether it's a number or a name or whatever. Okay. And I'm bringing those up just so we understand that principle of like the and it all must be true, or it can be selective. All right, what we're going to do next, folks, is we're going to jump out of the Brave browser here, and that was helpful, I think, to not see the ads. And we are going to take a 5-minute break. So I am going to pause the video here, and we will be back in